Okay, so up to this point, if you look at that in the chapter 2, we started to talk about the different method we can use um, to solve the circuit, if you have a circuit. So we started with the, at the very beginning of chapter, we worked with the series and parallel resistance, and see if we can simplify the circuit by using this series and parallel resistance to the simplified circuit. That's probably the best bet we can do. Go ahead and we simplify it and then solve the circuit. Then after that, we start talk about it. What if we cannot simplify the circuit by using just series and parallel laws? In that case, we started to look into the previous method that we have it in the node voltage method. So we went to the node voltage method, show that how we can write the Kirchhoff current law at every given nodes and then solve them all the equation together and to basically analyze the circuit. The next method is that we are going to use it for analyzing a circuit. It's called the mesh current method, and this is what we're using it. Is another way of analyzing the circuit if it's not simple to be done, just like using the parallel series resistance. So the next method is the mesh current method. And it's remember in the previous one when we talked about the node voltage method, what we did is we will go ahead and take off every node in the circuit and we write the Kirchhoff current law for that node. Now when we talk about the mesh current methods, that we will go ahead and we pull out every loop in the system and we wrote the Kirchhoff voltage law for that. So just if I want to go one step back, is that basically when we talk about the Kirchhoff current law, we have two Kirchhoff laws. We had two laws. The first one was Kirchhoff current law, which was saying that all the voltage goes into the node should leave the node. So basically the net current goes to the node should be zero. Whatever goes in the node leaves the node. So it was a Kirchhoff current law, and we used that Kirchhoff current law in the node voltage method. In the previous method we had. The second law, the second Kirchhoff law, was the Kirchhoff voltage law. I would say that if we have a loop, all the voltage in that, if we add all the voltage in that loop, it should become zero. And this is the method that we are going to use today for the mesh current method. So basically for the node voltage, we use the Kirchhoff current law. For the mesh current, we use the Kirchhoff voltage law to solve it. Now let's just to give an example, see how it works. So let's look at an example. So assume I have a battery and then it's connected to resistance here. There's going to be resistance here. There's going to be a resistance here. Then I'm going to have another battery here. Or voltage source here. And then these are all connected to each other. So assume we have these, and it's going to be R1, R2, R2, and it's going to be R3. So we have a circuit like that, and we want to analyze that circuit. So if we call this VA, call this VB, okay. Now that I think this is what we have in the mesh current method. The very first step that you are going to do is that you are going to basically define the meshes, or in other words, you're going to define the loops that you are going to use. So here I have this loop here. That's a closed loop. Remember the Kirchhoff Voltage Law. What it says is that if you have the closed loop and you add all the voltage in that loop, they should come as 0. So that's the very first step we are going to do here. Define the loops that we want to use. So this is a closed loop here, one here, and also there's a closed loop here. We are not going to use it right now, but also we can have the outside loop. So the loop that's going into the very outside of that, ignoring this middle wire, this one. So first I'm going to have, say, this is one loop and this is the second loop that I have. Then I'm going to assign a current to each of these loops separately. So I assume that there's a current in this first loop. Just assume the rest of the circuit is not there. Assume that's the only loop you have. Then assign a current to that. And then you have to choose both the magnitude and the direction of the current. So usually in this case, I'm going to consider that it goes clockwise. So I'm assuming in the loop one, the loop that has the VA, R1 and R3, this loop one, I have the current going like that. So it goes clockwise and the magnitude of that is I1. Assume that this part is not there. So I have only this loop, and I assume the current goes from the VA to R1 to R3, go back to VA is I1, and in this direction. Then go to the second loop and do the same thing. So assume this is the loop I have, and this is the only loop I have, and I want to assign the current and the direction of current in that loop. So I would go ahead and say, okay, I assume again if the current rotate clockwise, and the current with the second loop is going to be I2, whatever it is. So in the loops, the second loop, I assume the current goes, for example, from the R3 to R2 to VB and comes back to R1. So ignore this, the left part. Assume this is the only loop we have and everything goes there as I2. So I1 and I2. So assign the I1, I2. In other words, look at each loop, look at every loop in the circuit and assign a current and the direction to each one of them. Then start to write the Kirchhoff Voltage Law for each loop. So Kirchhoff Voltage Law at loop 1, for example. I want to write the Kirchhoff voltage at loop 1. This is the loop 1. I want Kirchhoff voltage law. What the Kirchhoff voltage law says is says that if I start to add all the voltage in that loop, they all should, and add them together. So if I add all the voltage in the loop, it should come as 0. In other words, sigma V in the loop should be 0 if I add all the voltage in the loop. So if I start from here, for example, I start from this point here, and I start to go and come back and write the Kirchhoff voltage law. So if I come here, the first thing I reached at is the negative sign. So remember, when we write the Kirchhoff voltage law, if we first reach the negative sign, we put the negative. If we reach the positive sign, we put the positive. So I go there, reach the negative, so it's going to be negative VA. And then I keep going. Remember that it always, because in resistance, the current is always goes from positive to negative. So if the current, I assume the current goes in this direction, it always goes from positive to negative. It should be like that, because in the resistance, current always goes from positive to negative. The same here, it goes from positive to negative. If I want to, if I assume this is the direction of my current, and assume that's correct. If the current goes this way, so the first one should be positive, the second one negative. Again, this first one positive, second one negative. So then the voltage in this one. How much the voltage in this one? Remember, the Ohm law was saying that the V is IR. The voltage in the resistance is like that. So the voltage in this one is going to be, first of all, is the plus, because we get to that, and it's going to be I1 R1. So it's the voltage in this one. Then plus, again, now I'm going to this one, the voltage in this one, because I'm in the loop one and I want to write it. Plus, now the voltage in R3. How much is the voltage in R3? So if I want to write the voltage in R3, I have to write the IR. The R I know is R3. So we don't have any pro. So the R is R3 for the voltage. But what about the current? If you look at it here, if you look at this one here, and look at the current that goes through it, through the left loop. So for the left loop, I'm gonna for loop one, if I want to write, if I look at the whole thing from the loop one, it's gonna be, so we have the R3, and in the R3 we have so we have the R3, and we have the I1, and we have the same I2 at the same time. So the I1, if I look at the R3, the I1 going downward, and the I2, if I'm rotating, going upward in the R3. So I'm rotating this direction, I'm rotating. So everything is in the direction of my rotation is going to be positive. Everything is against my rotation is going to be negative. I'm rotating clockwise, and I1 here at this point, when I'm looking at this point, I1 is has the same direction as I rotate. So I'm going to put the plus I1, and the I2 is against the direction I'm rotating. So it's going to be negative I2. And then, so again, I'm rotating in the loop one. So I go from VA, then I go to the R1, then I go to R3, and go back to where I started. So it should come as 0. So it's going to be my first equation. So the voltage at the battery, the voltage at R1, and the voltage at R3. Then I have to write the same thing. So the KVL for the loop 2 in the same manner in the loop 2 says, if I go in the loop 2 all the way around and add all the voltage together, it should come as 0. So I start from this point down here and start to rotate in that loop. You can start from any other location in the loop. So if I write the KVL at loop 2, again, it says that if I add all the voltage together, it should come 0. So if I start here, and now this time I start from the R3. So the voltage is R3, I know that's the current times R3. So the R3 is, I know that. But this time, for loop 2, again, if I look at it, it's going to be the very same thing. So I have the I1, and then I have the I2. But what's the difference between these two? In the node 1, when I was in the loop 1, the I1 was in the direction I was rotating. The I2 was against the direction I was rotating. So it was I1 minus I2. So the I was there. Now when I'm in the loop 2, look at here, in the loop 2, the direction I'm rotating is that the direction I'm rotating is going from bottom to top. So the I2 is not in, has the same direction as I rotate, and the I1 is opposite of the direction I'm rotating. So the I2 is with the same rotation, with the same direction I rotate. The I1 is the against the direction I'm rotating. So now this time, anything is has the same direction with my rotation is going to be positive, which is going to be I2. Anything is going to be against the direction, it's going to be I1. So this time is going to be just the opposite of the what we have because of the rotation we have. So now it's going to be, this time it's going to be I2 minus I1 R3. Then plus, if I go ahead again here in the R2, because I'm rotating in this direction, it means that I go from the left to right, so it should be positive at the left, it should be negative, because always the current goes from positive to negative in the resistance. That's what we know. So if I rotate from this direction, I go from the left to right, so left should be positive, right should be negative. So it's going to be positive, and it's going to be I2 R2 based on this equation, based on Ohm's law. It's going to be I2 R2, and then I hit the positive sign of the voltage. It's going to be plus VB is going to be 0. So these are the two equations I'm going to have for the loop 1, and then I have it for the loop 2. Now in this case, the VA is known, so we know the magnitude of VA. We know the magnitude of VA, we know the magnitude of VB, and we know the magnitude of R1, R2, and R3, and we want to define I1 and I2. So we want I1 and I2. So basically, I'm going to rearrange this equation into two equations. So what I have, if I call this 1, I call it 2. The first equation, what the first equation is going to give me is that if I rearrange it, everything based on I1 and I2. So what I have here is going to be R1 plus R3 I1. So for this case, and for the I2, I have negative R3 I2, and then take every constant to the other side, so it's going to be VA. And then the same for the second equation. If I write all the coefficient for the I1, so I have on the I1 here is going to be negative R3 I1, and then plus for the I2, I have R2 here. So I have the R2, and then I have the R3 here. And so I have the R2 and R3 for the I2. And then I take all the constant to the other side. So the constant I have is this one, so it's going to be negative VB. And then now I have two equations, two unknown. And then when I solve this, it's going to give me I1 and I2. And when I have the I1 and I2, I can calculate the voltage in every element, or the current in every element of the circuit. And basically, this is how I analyze the circuit, and I have everything I need to have. Okay, so let's look at another example, a little bit more complicated example. Still, I'm not going to put any values there. So just look at the example, and then later on we'll start to have some values also. So here, assume that I start from here. So I have and then I have the voltage source or battery here. And then I have, this comes here. Have the voltage source here. And then I have another resistance here. Then another resistance here. And then I have another resistance on the very top. So VA is going to be VB, it's going to be R1 at the very top, R2, R3, R4. Okay, yep. Assume this is what we have, and we want to analyze this circuit. Again, when we want to analyze the circuit, as I said, the very first step you have to do is you need to go and define your mesh or loop, and then define the current in each of those mesh or loop. So here, for example, I know that there's one loop here, there's one loop here, and there's one loop at the very top. So I have 3 loops I can consider here. Instead of any of these 3, I may consider the outer loop as well. But here I'm just considering these 3 loops here. And then I have to consider the current and the direction of the current. So I assume in the loop 1, I consider this one's going to be my first loop. And I assume, again, the magnitude of the current is I1. And it's rotated like that. So the direction of the current in this loop is like that. For this one, for the second loop, I assume this one is my second loop. And the current goes this way, and it's going to be I2. So it's the magnitude is I2, and the direction, I assume, is going to rotate it clockwise. And then I would consider for the third loop, I consider this loop at the very top location. I consider that as a third loop. And I assume, again, this is rotating like clockwise, and the magnitude is I3. So I have I1 in the loop 1, I2 in the loop 2, and I3 in the loop 3. And after that, after I have this one, I have to start to write the Kirchhoff voltage law for each of them. So let me mark them with so for example, here, if it's the R1 and it's the V1, and this one is R2, and assume the voltage in that is V2. And here we have the R3 and assume the voltage is V3, and we have the R4 and assume the voltage in that is V4 in what we have. So at loop 1, if I let the KVL, the Kirchhoff voltage law, at loop 1, what it says that if I add all the voltage together, sigma V should comes to 0. So the loop 1, I'm going to start to rotate from this the lower corner here and rotate to in the loop one until I go back there. So in the loop one, what I'm going to have is that I start to rotate. So first I hit the negative sign. So it's going to be negative, and the magnitude of the voltage is VA. And then I goes here in the resistor here. As I said, because there is the positive negative is always in the direction, is always goes from positive to negative. In the mesh current, we always have positive for resistance. So it's a positive V2. And then I come here and I have the positive V3, and it's going to be 0. Now I'm going to replace them, everyone that I can, with the Ohm law. So VA, I already know what it is and I don't need to replace them, so it's going to be the VA. But the V2 from the Ohm law, I can write it as a I and R. So remember I write it here again. The Ohm law says is V is I times R. So I want to replace the V2 with that, with the IR. So R, I know it's the R2. And then I have more than one I goes through that. Every I goes in the direction of the rotation is positive. So if I consider the R2, the I1 goes through that in the positive direction of my rotation. So it's going to be I1. Now the I3, if you look at this, the I3 also goes through the R2. The I3 also goes through the R2, but in the opposite direction of my rotation here. So it's going to be negative or minus I3. So if you look at here, what I have at, see if I find it. So here, when I look at this specific one, the I1 is like that, and the I2, the I3 is like that. The I1 is has the same direction as my rotation, so it's going to be positive. The I3 has the opposite direction of my rotation, but my rotation is like that. I1, I'm going from the left to right. I3 goes from the right to left, so it's going to be negative I3 and R2. Then again, it's going to be voltage at R3, and then again, based on the Ohm law, I know it's the IR, so I know the R is going to be R3, so the R I know it is. Now I have to write the current goes through that R3, and if I look at here, what current goes through R3, so I know the I1 goes this direction, and the I2 goes up. Again, I1 has the same direction as my rotation in loop 1. So it's going to be plus I1. And then I2 is in the opposite direction of my rotation here. I'm rotating, going like that. So basically I'm going from up to down, and the I2 goes from bottom to top. So it's going to be negative I2, and then it's going to be 0. And eventually, if you look at this equation, by the time you're doing it, you even don't need to remember that always it's going to be the I inside the loop minus the I outside, comes from the outside the loop. So here I1 minus I3, here I1 minus I2. So after you write one or two of them, you even don't need to remember them. Always you subtract the I inside the loop minus the I's outside the loop. In most cases, I don't want to say all cases, but in most cases, they're going to be in the opposite direction. Unless you consider the I2, the rotate counterclockwise, then it's going to be another story. But in most cases, I would say it's going to be current inside the loop minus the current is outside the loop in most cases. So this is the equation I have for the first loop. Then I have to go and do the same thing for the second loop. So I run the KVL at loop 2. Again, it's going to tell me the sigma V, it should be 0 at the loop 2. So in the second loop, I start from this point here and I'm going to rotate. So if I go from here, I have the V3. Then I'm come here, I hit the plus sign first. So it's going to be plus VB. And then I have the plus V4 is 0. And why I put the consider V3 and V4 positive, again I said that when we rotate when we move in the resistance, if the plus and the current, the negative sign is that the current always goes from the plus, always goes from the positive to negative in the resistance. So if I assume the current goes this way, so this should be positive, this should be negative. So if I go here in the R3, this one is the positive, this one is the negative. Remember, if I go back in the I1, again, I1, I rotate goes from left to right, so it's going to be positive, negative. Then I go from the top to bottom, it's going to be positive, negative. So positive and negative sign, if I'm in the loop 1, is completely opposite of if I'm in the loop 2. Just remember that. In the simple format, when you are do the mesh current, just add all the voltage in the resistance. It's just easier way of doing that. Add all the current, all the voltage in the resistance. Don't worry about the sign. So when you're doing the mesh current, just simply add all the voltage for the resistance. Only be worried about the voltage in the only look after the sign for the voltage in the battery. So if you hit the positive, put the positive. You hit the negative, put the negative first. Now, if I go ahead and then for the V3 here, again, I know this is the R3 is that. And now this time, look at the E3. Now the I2 is in the direction of my rotation, and I1 is opposite of the direction of my rotation. So it's going to be I2 minus I1, then plus. Here the VB, we know that is the voltage, we have the magnitude, and then we hit the R4. We are going to have only I2 in that. So it's going to be I2, R4 is 0. There's no other current goes through there. And now I would go to I write the KVL at loop 3. Again, it tells me the sigma V should be 0 at the loop 3. So the loop 3 is up here. And I have to start from one location and go all the way, come back to that location. So I would start from here at this location. So I'll go all the way into this one's going to be V1. Then I comes back, I hit the negative sign of the VB, so it's going to be negative VB. And then I keep going, I hit the V2, so it's going to be plus V2, and it's going to be 0. So again, if I put replace the V1 with the Ohm law, so it's going to be R1 I3 because there's nothing else is going there, so it's going to be I3 times R1. Nothing else is there, so only I3 goes there and the R1. Then I have the voltage, which I know the magnitude. And then I have the V2. I have to replace V2 with the IR. And then if I look at it, so the R is R2. And then the magnitude of the I goes through the R2 is that I3 has the same direction as we rotate. So it's going to be I3 plus I3. And the I1 is the opposite of direction of what we rotate. So it's going to be negative or minus I1. And it's going to be 0. So now we have equation 1, equation 2, equation 3. So we have 3 equations here. And we have I1, I2 and I3. So we have three equations, three unknown. So the same as previous example, we have to rearrange them as a format of I1, I2, and I3. So if I want to rearrange them in the format of that, so I write here for the I1. So for the I1, I have the, so that means the equation 1 gives me, so I'm gonna get the coefficient for the I1. So for the I1, I have R2 and R3. So I have the R2 plus R3 I1. So R2 and R3 I1. Then for the R2, for the I2, so it's the I1. Then the I2 is the negative R3 I2. And then for the I3 is the negative R2 I3. And then move the constant values to the other side. So it's going to be VA. So it's going to be the first equation. So for the I1, the R2, R3, for the I2 is the negative R3, for the I2 negative R3, for the I3 is the negative I2. Then write it again, the second equation as a function, the same as a function of I1, I2, and I3. So for the I1, again, I have the negative R3 I1 here. Then for the I2, I have the R3 here. And then I have the R4 here, plus R4. It's going to be I2. Then for the I3, I don't have any I3 here, so it's going to be 0. Remember, always write the 0 if you don't have it. And put any, if you have any constant value to the other side, which is going to be negative VB. And then the third equation. So that again, double check. So for the I1, negative R3. For the I2 is the R3 plus R4. We don't have any I3, and the VB go there. And then for the last equation here, again, for the I1 is negative R2 I1. Then for the R2, we don't have any R2 here, so I put the 0 R2, 0 I2, sorry. We don't have any I2 here. And for the I3, what we have is we have the R1 and R2. So we have the R1 plus R2. So it's R1, R2 times I3. And then we take the constant to the other side. It's going to be VB. So we have three equations, three unknown. And then if I go ahead and put them in the matrix format, that's what I want it to be eventually. So I'm gonna have them to written as here, for example, it's gonna be R2 plus R3. Then for the R2 is gonna be negative R3. Then here is a negative R2. For the second equation, I have the negative R3. I have R3 plus R4. And then I have 0 here. Then for the last one, I have negative R2. I have 0 here. And I have R1 plus R2 here. And then if the unknown matrix is going to be I1, I2, I3. And then the constant values is going to be VA, negative VB, and VB. And if I rearrange the equation correctly here, so this is the matrix format of that. And if we know the values in the problem that we're going to solve, we know the value, all the values of R. So we have these coefficients matrix. We know all the values of sources. These also, we know these coefficients as well. So if you punch it in your calculator, it simply is going to gives you the magnitude of I1, I2, and I3. So let me also remove these parentheses here so they look the same. So this is how we are going to solve this equation, this problem. So basically it's like that. When we are designing or we are analyzing the circuit, we know the physical element that we have in the circuit, which are going to be the voltage sources or the resistance. These are the physical elements we put in the circuit. Then we want to see if we have this arrangement of these physical elements, how the current is going to start to go around in this circuit, how the voltage is going to be distributed in this circuit. And this is all these methods that we are using up to this point. We only look at for the current and the voltage. That's all we look into that. Everything else assume to be known. So now let's look at an example with the numbers. So see what how actually, if we do have the numbers, how we are gonna work with that numbers. So assume I have a voltage source here. So it's going to be resistance, another resistance here. Then I have resistance here. I have a voltage source here. Then I have these two are connected, and then I have the resistance all up here. So it's gonna be 70 volt, and this one's gonna be 42 volts. It's going to be 10 ohm. It's going to be 12 ohm. It's going to be 20 ohm. And 14 ohm. Is this all? Yeah. 20, 12, 10, 14, 70, 42. So assume we have this, and we are asked to analyze this circuit. If we are asked to do it with the mesh current, so this is how we are going to do that. If we are not told how to do that, so we can either use the mesh current or we can use the node voltage method. But here, because we are working in the mesh current, we use the mesh current method to solve it. But we could have used a node voltage method as well. Now, again, when we are dealing with this kind of circuit, if we are doing the mesh current, is that we have to define every loop and then define the current in the loops that we have. Again, in this, I'm always consider the current rotation clockwise. You may consider the counterclockwise one, but I always consider them clockwise in all the loops. It just make it easier. So I consider this one to be my very first loop. So it's going to be I1. So the magnitude is the I1 and the rotation in my loop is going to be the clockwise. The second one, I consider this one as the I2. And again, they'll consider the rotations clockwise. And the same here for the loop that I have at the very top is going to be I3. And the rotation also is going to be the clockwise rotation. In that loop, so I assume the current rotate clockwise in there. Okay, now again, I'm going to start to write the, let me put the voltage so I will know what I'm doing. So this is I know that, let's call it, so this is the VA, I call this V1, call this, assume for example, it's going to be V2, going to be V3, it's going to be VB, and it's going to be V4. Remember, this V1, V2, V3, V4, I put it here, it's just for make it a little bit more clear what I'm doing. When you get more comfortable, you don't need to do that. You just write straight away. You can go to the equation and write the equation. But I just put it there, just make it a little bit more clear where all those numbers coming from. So loop one, I started at the loop one. So I write the KVL at the loop one. And start to write it again. Say the sigma V should be 0 if I add all the voltage. So I'm gonna start from here and rotate clockwise in this one. So go ahead and get to negative VA. So it's a VA and hit the negative sign, and then add all the voltage in the resistance. Always add the all voltage in the resistance. So it's going to be plus V1, and it's going to be also plus V2. And then I go back to where I started. There's no other element, so it's going to be 0. Now I'm going to replace these with their magnitude or the Ohm law. So the VA, I know it's going to be 70 volts. I already know that, so it's going to be minus 70 or negative 70 here. Then for the V1, I replace it with the Ohm law, which is going to be IR. So the R is 20. I know it's going to be 20. And the I here is that I know how the I goes. So I1 goes this direction and I3 goes this direction. So it's going to be I1 minus I3 if I rotate in clockwise, because I'm rotating clockwise in the loop one. So it's going to I1 minus I3. I1 minus I3. And then I go in this one. Again, if you look at in this one, how the current goes, so it's the I1 going this way. And then the I2 going up. So it's going to be I1 minus I2. The current goes through this one. If I rotate clockwise, it's going to be I1 minus I2 and times 10. So it's going to be I1 minus I2. So inside minus outside times 10, and it's going to be 0. So the same I can write for the second one, KVL at loop 2. So sigma V is 0 again at the loop 2. So the second loop, I'm going to start from here and go all the way back to this point, and I rotate the clockwise. So if I go there, I just add the voltage in the resistance. So it's going to be V2, then plus the voltage in the resistance is going to be V3. And then for the battery, the battery is the only one you need to be worried about the sign. In this case, that you only have the resistance. So it's going to be positive, and then VB is 0. So V2, the magnitude in the V2 again is going to be, now I'm rotating here in the second loop. So my rotation, the direction of the I2 is with the rotation is the same as the direction of my rotation, and the I1 is the opposite of my rotation. So it's going to be I2 minus I1, or in simple word, inside current minus outside current times 10. And then here again, I have, if I look at here, I know that in this one, again, I2 goes this direction, and then the I3 goes this direction. So the inside minus outside, or the positive minus, so it's going to be I2 minus I3 times 12, and then positive VB, which is going to be plus 42. It's going to be 0. And then the KVL at loop 3. So I'm going to in the very top loop to see what I'm going to do there. Again, this time I'm going to start from this node, rotate all the way counterclockwise, and go back to where I started. So here I don't have any sort, I only have 3 resistance, so I'm going to add the voltage in there. So sigma V is 0, and I have V4 plus V3 plus V1. So add them, is going to be 0. So V4, I replace them again with the Ohm law for the V4. The only current goes to the V4, or this at top resistance is the I3. And so it's going to be I3 times 14 plus, here I have the V3, and for the V3, again, look at that. The I3 is has the same direction as my rotation, so it's going to be positive. The I2 has the opposite direction compared to the rotation I rotate, so it's going to be negative. Or in simple word, the inside minus outside, so it's going to be I3 minus I2, and then you have 12 volt here. And then the same for the next one here. I come here again, inside minus outside, so you have it I3 minus I1 times 12 times 20. It's going to be 0. So I have equation 1, I have equation 2, and I have equation 3. I have 3 equations, and in this case, to solve them. Now, this is mostly what you're going to get, that you have the problem with the values and you need to solve them. So I'm going to write them, I'm going to write this one up to the very last point to show you how actually we do that from there. So if you remember from previous example, what we need to do is that we have to go and rearrange it based on the unknown. The unknown is I1, I2, and I3. So I have to rearrange each equation as a function of I1, I2, and I3. So I start from the equation 1. So here we have our 3 equations. Now I go from the equation 1. So I first write all the coefficients for I1. So for the I1 here is 20, and then I have 10. So the 20, 10, so I have the 20 plus 10 times I1, and I don't have any other coefficient. Then I go to I2. For the I2, I have only this one is a negative 10, so it's going to be negative 10 I2. And then for the I3, I have only one term here, and it's a 20, so it's a negative 20 I3. So I write I1, I write I2, I write I3. Then I move all the constant to the other side. So it's going to be, I put this negative 70 to the other side, so it's going to be 70. So it's going to be my first equation. So one more time, just for the I1 is the 20 and 10, for the I2 is negative 10, for the I3 is negative 20, and this. So the second equation, go to the second equation. Again, I write all the coefficient for the I1 first. So I have only one term, so the negative 10 I1. Then I write all the one for the I2. So I have the 10 here, 10 here, and here I have the 12, so plus 12. I2, so the 10 and 12 for the I2. And for the I3, I have the negative 12 I3. And then I move the constant value to the other side, so it's going to be negative 42. For the third equation, here, again, I start with the I1, so the only term I have the I1 is this one, so negative 20 I1, plus for the I2, if I go here, I look at here, so I have only one term that has the I2 in it here, as the negative 12. So the negative 12 I2. And then, so that's the I1, that's the I2, and the rest is the I3. So for the I3, I have 14 here. Then I have 12 here. And then I have 20 here. And then if I have any constant value, I take it to the other side. I don't have, so the other side is gonna stay 0 in this case. So if you look at that, now I simplified just, these are the three equations I have. I rewrite them as a function of I1, I2, and I3. So everything rearranged just in format of I1, I2, and I3. Now I'm gonna put them in the matrix format. So the coefficient matrix is the just the coefficient of I1, I2, and I3 for each row. So for the first row, the coefficient of I1 is 20 plus 10. The coefficient of I2 is negative 10. And the coefficient of I3 is negative 20. Then the second row, the coefficient of I1 is negative 10. The coefficient of I2 is 10 plus 12. And the coefficient of I3 is negative 12. And then the third row is the coefficient of I1 is negative 20. The coefficient of I2 is negative 12. And the coefficient of the I3 is 14 plus 12 plus 20. So that is my matrix of the coefficient matrix. Then I have the unknown values, which are going to be I1, I2, and I3. And then I have the constant value in the other side, which is going to be 70, negative 42, and 0. And if I solve this, if I plug this into the calculator, eventually it's going to tell me the magnitude. Let me see if I have them here. So I1 is going to should comes out 4 if I write everything correct. So it should comes at 4 amp. The I2 should comes at 1 amp. And the I3 should come out as 2 amp. So if I write this equation, if I rearrange them right, I have the sign correct. This is what we are gonna get. So this is the part. So this is the part. This matrix is the coefficient matrix. You need to put it in your calculator, and this matrix is the constant matrix. You need again to put in your calculator, and then it solves it for I1, I2, and I3.